The second section in Unit 2 is titled Rational Numbers. And again, we're focusing on standard 7.ns.3. So with rational numbers, by the end of the lesson, you should be able to identify, compare, order, and plot. The definition for today is a rational number. And a rational number is any number that can be written as a fraction. And please write the examples here because we're going to talk about each one of these. But a terminating decimal is what you see first. That's that 0.87. This is a terminating decimal. And all terminating decimals are rational numbers. Obviously, 2/3 is a fraction. That's the definition of a rational number, that it can be written as a fraction, so all fractions are rational. Whole numbers, actually this is an integer. If you think for a moment, integers, whole numbers, natural numbers, we can write them as fractions by putting them over 1. So any whole number or integer over 1, that makes it a fraction, which makes it a rational number. Mixed numbers, there's an argument that mixed numbers themselves are fractions, but if you candy cane this, 1.5 becomes 3/2. We write it as an improper fraction, then that makes it rational. And then finally on the end we have repeating decimals. We don't spend too much time yet focusing on how to write repeating decimals as fractions, but they can be written as a fraction. If you think about a really common repeating decimal, 0.3 repeating, most of you could probably tell me that 0.3 repeating is 1/3. And for all repeating decimals, you can write them as fractions. So let's write each rational number as a fraction. So the first one is a mixed number, 6 and 1/6. So we're going to candy cane. We multiply the whole number times the denominator. 6 times 6 is 36. Then you add the numerator, so that gives you 37. And you write it over the denominator, which was 6. So 37/6. Number 2, again, we're just going to put the integer over 1. If you'd like to pause the video here, try 3 and 4 on your own and then check with what I get. When you candy cane number 3, 4 times 3 is 12, plus 2, you get 14/3. And number 4, we have a whole number, we just write it over 1. Next we're going to talk about how to write terminating decimals as fractions. You do need to make sure that this goes into your notebook and that you've written these steps down. So when you're writing a terminating decimal as a fraction, the first thing you need to do is look at the last place that the decimal goes out to. So for example, in 0.64, the last digit is in the hundredths place. It's in the hundredths place. So then you're going to take that 64 and divide it by 1 and the same number of zeros that there are in the digit. So in this case there are 2 digits after the decimal, so we're going to divide it by 1 and 2 zeros, or a 100. So in this example, if it goes out to the tenths place, you divide by 10. If it goes out to the hundredths place, you divide by 100. And then you always reduce the fraction. This is read, this decimal is read as 64 hundredths, so that would just be 64/100, and then you would reduce. And we won't do that just yet because we'll do some examples. So write each decimal as a fraction in simplest form. Paying attention to the digit, the last digit in the decimal. So here we have 0.84 or 84 hundredths. That 4 is in the hundredths place, so that means we write 84/100. and then we need to start dividing. I know that 84 and 100 are both divisible by 2. They're also both divisible by 4. So 84, it's 21 over 25, and that is in simplest form. Example 6, we have 5 and 875 thousandths, if you want to read it that way. Some people read it as 5.875. We're going to ignore the whole number for a moment, and we're going to focus on the decimal. So we're going to ignore that whole number for a moment and just focus on the decimal. That 875 ends in the thousandths place, so it needs to be divided by 1,000. When you start your division, you can start with the simplest one you know. They are both divisible by 5. They're also both divisible by 25, so I'm going to start there with 25. So then you have to start thinking, how many times does 25 go into 875? We still are not using a calculator on this unit. 25 goes into 104 times, and there are 8 hundreds. So 8 times 4 would be 32. Then it goes into 75 3 times, so 32 plus 3 would be 35. 25 goes into 100 4 times, so it would go into 1,040 times. 35 and 40 are both still divisible by 5. 35 divided by 5 is 7, and 40 divided by 5 is 8. So 0.875 is 7/8, but remember we also have the 5, so then it becomes 5 and 7/8. And since our fraction is reduced to this mixed number, now we're going to write it as an improper fraction. That's 47, 5 times 8 plus 7 over 8. So I would accept either answer here, the mixed number or the improper fraction. This chart I just want you to focus on. This is what we call the real number chart. And on the left-hand side you see rational numbers, which is everything we discussed today. We see improper fractions, we have decimals, fractions, positive and negative. You see repeating decimals. What you don't see up here are also terminating decimals. Oh yeah, terminating decimals. Here's the 4.5, that's terminating. We have integers, so all the negative whole numbers, and the natural numbers. We don't have to focus so much on these different categories, but you do have to understand that they are all rational numbers. Any whole number digit can be divided by 1 to make it a fraction, so that's why they're all rational. On the irrational side of things, we have pi. That's the most common irrational number, because irrational numbers are decimals that do not terminate and they do not repeat. And it's important to understand that. Some other common irrational numbers are numbers where you're trying to take the square root, but the number is not a perfect square. So 2 is not a perfect square. 17 is not a perfect square. Square root of 11 is not a perfect square. Some examples of perfect squares would be 16, because it's 4 times 4. Also 36, 6 times 6. Square root of 81. These are all examples of rational numbers because they're perfect squares. So if you have a number and it's under a square root and you're being asked if it's rational or irrational, you have to figure out what the square root of that number is. If it's a perfect square, it's rational. If it's not a perfect square, then it's irrational. The letter E is another common constant that you probably won't see till high school. It's 2.7 something, 2.71 I think, but that's another irrational number like pi, so it never ends and it doesn't repeat. So now let's classify the numbers as rational or irrational. So we have 0, and students sometimes get confused with 0, but I could write 0 over 1, and that would be a fraction, so 0 is rational. Again, we've talked about mixed numbers several times. I could write that as 9 over 5, so that makes it rational. And in example 9, be careful here with decimals. This is pi, but notice the dot, dot, dot. That means it would continue on. You don't see a pattern here. Digits don't repeat in the pattern, and it appears to never end because of the dot, dot, dot. So pi, again, is irrational. In class, we'll work on worksheet 2.2.